10 nationalities are, let's say, in-house here by our designer groups, and we have also all the time employed students for R&D projects as well as assisting in commercial projects, and we support them for his master or bachelor thesis preparations. What is our performance? Here you see what we are doing: market analysis. We make potential analysis for ship types. We make feasibility studies, how it works, or how it should work if a client is coming to us with his request. And what we are doing then is called first initial design with datasheet development. We take basic designs that are packages which has to go to class approval or national authority approval. We take detailed designs, 3D models, and workshop designs for yards or factories. They are building maritime products, let's say, not only ships, also some other maritime products. We make also tender packages for the negotiations, what shipyards has to do with owners, and we make them as well assistant during project management, inquiry, procurement management, and sea acceptance test and factory acceptance test of equipment. Okay, that gives us a big contact amount to ship owners and yards, as well to classification societies and equipment suppliers around the world. Our R&D projects in the moment are looking mainly to alternative propulsions, e-fuels, lightweight constructions, and offshore wind marine technologies. We are members from Verein Schiffbau und Meerestechnik in Germany as well, the local, let's say, community of called REGWA, where ship suppliers and maritime supporters are, let's say, collected together. Here we have 3 names which you can find on our webpage as well, called Neptun Hopper, Neptun Mover, Neptun Shoe, that are products we have designed for electromobility in inland waterway vessels. Okay, first, please visit this page. The second one will come, it's called Intro 1, because here you see a best practice proposal or project. This is the Futures of the Fjords. It's built in 2018 in Norway. It is a vessel. It's running on fjord from Flam to Gudvangen in Norway. It has these sizes which you see here, can transport 400 people, and it is moving on distance of 55 kilometers around the fjord, fully electrical. And this vessel is built in carbon fiber hull. You see the electrical propulsion of 2 times 450 kW, which pushes up the vessel to maximum 16 knots. And as you see it here on the right page, on the bottom, it is berthing on a power dock, where also cars can be charged on short side. As well, batteries are installed to feed the ferry quick as possible for the next voyage term. This is charging up the battery of 1.8 megawatt hours in 20 minutes. Please remember, two points are marked in red here. I will tell you later why. Next intro, this one. It's the Ampere. Somebody from you knows it, I think, very well. It's an electric-driven personal and car and truck ferry, also running in Norway, between Leivik and Rotterdam. It's an aluminium hull, and it has also auto mooring and auto charging systems. This is, let's say, a really reference, what should be focused on in the community of industry, which is looking to the electrical e-mobility or the e-mobility. The e-mobility in the commercial business has these technical and commercial principles. We have the situation that batteries have a less energy density from 200 watt hours per kilogram instead of diesel, which is a huge value of 11,800 watt hours per kilowatt. And the problem is that we have the energy in the vessel not anymore in tanks. We have it in battery rooms, which also to be considered according to the requirements and rules to be used during design and build of the vessel. And we have to look for safety concepts for such kind of e-ships and large charging logistic, and as well to related costs. What is the solution approach number one? We have to bring the energy demand for the propulsion of the hotel to a minimum as possible. And this is done by an effective energy management system. And remember the red marks before: lightweight construction, optimized hydrodynamics, optimized voyage profiles, digitalization, photovoltaic, etc., and automatic charging and mooring systems. And we have the solution approach number two. We have to take traditional voyage profiles in question, energy demand in question, charging demand in question. We have to define battery configurations and charging configuration. Do we do it by a pantograph or by cables or by induction? It's a question mark. And we have coordination with the net suppliers to be done for this vessel, for this project, for maybe a group of vessels running together in a business. And that means effective concepts for marine e-mobility requires deep technical, logistical, and vessel berth studies and analysis. And a successful business model is only realizable by new building projects, where a vessel, a docking, and a charging has to be in a functional context. Here you see the main document during design of an electric ship. It's a proposal to show you the consequences. It's a so-called battery calculation, where you have to make, according to the voyage profile, according to the standing on berth profile and timing, how much energy you need during the voyage and how much you have to push into it for the next voyage. And this is one of the main documents before you start to design a vessel itself. Okay. The next one, it's a so-called the single line diagram. We have with electric ships a big focus on the electricity in this ship to do. And you see a lot of marks related to the motors, switchboards, transformers, batteries, etc. But here, and that's why I mark it in red, is a point which is one of the main points to be considered. It's a connection to berth. Do we do it by a manual cable, by hand, or do we do it by an automatic system? That requires total technically different views of engineering. What is the findings? The findings are that yards and his selected suppliers, mostly often used suppliers, are only interested and highly interested to sign a contract for vessel building. And the focus from them is only looking to capex. A steel hull, for example, reflected to corrosion, is heavy. That means the vessel needs more energy for propulsion. A manual charging needs more battery in the ship, what is also considering weight increasing. Again, energy consumption. The focus is not by them on OPEX. Means more energy consumption means more electrical costs, and more battery volume requires also more maintenance and exchange of a big package in 7 or 10 years of his lifetime. It's also again an investment. We have to remember that. European tenders, which mostly municipal operators has to do, they are looking always to the best commercial proposal or economical proposal. So as they are considering only the vessel price, they are considering not the berthing price, the mooring price, the charging price, etc. That means the governmental foundings are not focusing enough on high innovation projects. E-ships are preferred references for yards, suppliers, operators, communities, but not if it's the cheapest possible model. Conclusion: the main market barrier are mostly the involved yards itself. They take in capex view primary, they take in OPEX view only secondary, and they take an innovation view on a third priority. Recommendation: private and municipal operators needs independent project and development. Yard independent project and design development. Take an innovation CapEx and OpEx as topic in the requirement booklet. Take an equipment maker selection according to technical evaluation. Not according to references, also not according in the first point of view of about pricing, according to the technical evaluation. Because a battery is not a battery. A battery from one supplier is totally different one to the other supplier. It's because of chemical parts inside and also cooling requirements, etc. as well lifetime calculation. The minimization of energy consumption is on the absolutely high priority. Automatization and digitalization needs to be on the highest priority. We are talking always about one-man operation or automatic operation and etc. This is only possible with automation and digitalization. Taking vessel berth, auto mooring, auto charging, and onshore net infrastructure. In summary, in the development, not only the vessel. Otherwise, we are buying a cheap vessel during an expensive lifetime of such. Please feel free to contact our project designer. Thanks for your attention. Here you can see a video from a project which we have developed considering all of what I have talked before.
Thanks, Mr. Arndt.
Yeah, I keep the time.
You kept this time very, very good.
Okay.
Thank you for that. So, okay, Romy and Liana, are there some questions in the chat?
Not yet. We don't have any questions yet. But can choose
okay, we have big feedback from your microphone. Okay, so I got some feedback that I was not good understandable on the end of the introduction. I switched my internet connection. Hope it is fixed now. Okay, let me go back to the agenda. So, yeah, thank you, Mr. Arndt, for this interesting presentation. At the moment, we have no question, but maybe that changes. We will see.
Okay.